Hello everyone, and thank you for continuing with this important series on AI fundamentals. In the last section, we discussed what large language models are and how they have emerged as powerful tools in today's digital society. Now, we move one step further. How do these AI models actually understand and generate human language? Although AI's grasp of language might seem natural or even intuitive when you interact with it, the underlying process is mechanical, mathematical, and fundamentally different from human thinking. Understanding this distinction is essential for policymakers because it highlights both the potential and the risks associated with deploying AI systems in sensitive areas like governance, healthcare, education, and national security. Let's begin. 1. The language processing pipeline. The process by which AI understands and generates language follows a highly structured pipeline. Let's walk through it step by step. First, input. Whenever a user types a sentence, asks a question, or issues a command, the AI system receives that raw text as input. Second, tokenization. Before the AI can process the text, it must break it into manageable pieces. This process is called tokenization. In simple terms, tokenization splits sentences into words, subwords, or even characters. For example, the sentence "I love democracy" might be split into tokens like "I love democracy." Some models use even finer divisions, breaking words into syllables or common fragments to maximize flexibility across languages. Third, embedding. Once tokenized, these pieces are not meaningful to a computer yet. The AI must then convert tokens into numerical vectors, mathematical representations that capture some aspect of their meaning, usage, or relationship to other words. This stage, called embedding, allows the model to interpret abstract ideas like similarity between words happy and joyful or relationships king is to queen as man is to woman. Fourth, processing. The vectors are fed into a vast, multi-layered neural network, typically based on transformer architecture. Here, layers of computations analyze the input for patterns, relationships, and structure based on what the AI learned during its training phase. Fifth, output. Finally, the model predicts the best possible response, a sequence of tokens that form the AI's generated text. This pipeline, while invisible to users, underpins every interaction with AI writing tools, customer service bots, automatic translators, and more. 2. Understanding context in language. One of the revolutionary advances in recent AI research has been improving how machines handle context, the backbone of meaningful communication. Early AI models struggled to remember what was said earlier in a conversation. They viewed text sequentially, one word at a time, losing the broader meaning. Today's models, using attention mechanisms within transformer architectures, have changed that. Attention mechanism. Imagine reading a long sentence and mentally keeping track of which words are most important to understanding its meaning. The attention mechanism does something similar. It assigns different levels of importance to different parts of the input text. If you say, "The trophy didn't fit into the suitcase because it was too small," attention mechanisms help the AI realize that it refers to the suitcase, not the trophy. Without such a mechanism, AI would frequently misunderstand references and relationships between parts of a sentence. Transformer architecture. Transformers allow AI to analyze all words at once rather than step by step. This simultaneous processing helps the model understand complex language structures, where meaning often depends not just on adjacent words but on long-distance relationships within a sentence or paragraph. Handling ambiguity. Natural language is filled with ambiguities. Words have multiple meanings. For example, the word bank can refer to a financial institution or the side of a river. AI systems deal with such ambiguities by assessing the broader context and using statistical patterns to guess the most probable interpretation. But despite these improvements, AI's understanding is statistical, not cognitive. It doesn't truly know what a suitcase or a trophy is. It only knows how these words typically appear together in text data. 3. How AI generates language. Now that we understand how AI interprets input, let's explore how it generates responses. Next word prediction. At its core, language generation is about predicting the next word. Given the phrase artificial intelligence can, the AI predicts what words are most likely to follow based on everything it has seen during training. It picks one word at a time, stringing them together into coherent sentences. Temperature settings. AI systems can adjust the creativity of their outputs using something called temperature control. A low temperature setting means the AI sticks closely to the most probable, safest outputs. Responses become more factual, formal, and conservative. A high temperature setting introduces more randomness, allowing for creative, diverse, or surprising outputs. This can be useful in brainstorming but risky in official communication. Sampling techniques. Instead of always choosing the most probable next word, models sometimes use sampling strategies. Top K sampling. The AI considers only the top K most likely words at each step and chooses randomly among them. Top P nucleus sampling. The AI looks at a flexible set of top probable words that collectively account for a high probability mass, e.g., 90%, choosing from that set. These mechanisms prevent AI from sounding robotic and repetitive, helping it maintain a more natural, varied language style. 4. Challenges and limitations. Despite the remarkable progress in AI language generation, there are important challenges and limitations. Literal interpretation. AI models can struggle with non-literal language, sarcasm, metaphors, humor, or cultural references. For example, if you sarcastically say, "Oh, great job," after a mistake, AI might interpret it literally as praise. Loss of context. In long conversations, AI models may lose track of details from earlier parts of the discussion. Efforts like memory-augmented models are trying to solve this, but limitations persist. Bias and hallucination. Bias. AI reflects societal biases present in its training data. It might unintentionally reinforce stereotypes or produce insensitive outputs. Hallucination. Sometimes AI generates information that sounds credible but is factually incorrect or completely fabricated. For instance, citing non-existent laws, fabricating quotes, or inventing historical events. 5. Practical implications for society and policy. Now let's tie these technical insights to broader societal and policy considerations. Information integrity. AI-generated misinformation can spread faster and more credibly than ever before. Policymakers must consider frameworks for detecting and mitigating false information produced by AI. Accessibility and communication. On the positive side, AI's language capabilities can dramatically improve accessibility. Instant translation across languages. Auto-generated captions for videos. Educational tools for underserved populations. Public services and governance. Government agencies may increasingly rely on AI for citizen engagement, document drafting, or service delivery. However, transparency must be built into these systems to prevent opaque decision-making and maintain public trust. Ethical standards. Policymakers must champion ethical guidelines that govern how AI communicates, especially in critical sectors like health care, law, finance, and education. Key questions include: should AI systems disclose when content is machine-generated? What safeguards should exist to ensure factual accuracy? How should liability be handled when AI-generated communication causes harm? Conclusion. To summarize, AI does not understand language in the way humans do. It processes patterns, predicts likely continuations, and generates output statistically, without genuine comprehension or intent. Its strength lies in its speed, flexibility, and ability to handle vast amounts of information. Its weaknesses lie in misunderstanding nuance, losing context, and occasionally inventing falsehoods. As policymakers, your role is to foster environments where these tools are used responsibly, ensuring that the benefits of AI-driven language capabilities are maximized while minimizing risks to individuals and society. Thank you for your attention. I look forward to your questions and to discussing how we can integrate these insights into effective, forward-looking policy frameworks.